So there they were, staring at the one thing they never expected to find. A gas, invisible, silent, sitting in a locked room, doing absolutely nothing, and about to kill a man who never even knew he was in danger. And honestly, if he'd known what was coming next, he would have just walked away right then. But he didn't. And that's where our story really begins. Because that same invisible killer, it's in your lungs right now, as you listen to this. You've been breathing it your entire life, every single second, and it has never once tried to hurt you until, in the wrong room, at the wrong moment, it turns into a silent executioner. Same substance, same ghost, two completely different faces. Here's the promise, and I'm not going to oversell it. I'm just going to tell you straight. By the time we're done today, you're going to understand a thing that is inside your body right this second, that built the sky above your head, that's flowing like frozen rivers on a dwarf planet 3 billion miles from here, and that gets divers drunk at the bottom of the ocean without a single drop of alcohol. You're going to walk away from this looking at the air around you completely differently. And yeah, there's a twist coming around the halfway mark that most people never see coming, even scientists who've studied this stuff their whole careers. So stick with me, because we're not just going to list facts today. We're going to get lost inside them. All right, let's start at the beginning. Take a breath right now. Go on, actually do it. Feel your chest rise. Cool, right? You just did something you've done, 20,000 times today already without thinking about it once. But here's the kicker. Almost none of what just filled your lungs was oxygen. 80% of that breath, roughly 4 out of every 5 parts, was nitrogen, a gas with no smell, no color, no taste, and get this, it doesn't even enter your bloodstream when you breathe it normally. It just passes through. A tourist, a silent hitchhiker riding along in every inhale and every exhale of your entire life, never once announcing itself. And that's kind of wild when you think about it, right? The most abundant thing in the air around you is also the most forgettable. Nobody wakes up in the morning thinking, man, I love breathing nitrogen. We talk about oxygen like it's the main character. Nitrogen's just furniture, background noise. But here's where it gets messy, because this boring gas is secretly one of the most dangerous, most bizarre, most shape-shifting substances in the entire universe. Squeeze it, freeze it, split it apart with lightning. Every single time, it turns into something almost unrecognizable. And today, we're going to trace every single one of those transformations, right up to the ones that could kill you without warning, and the ones that literally built the color of the sky over your head. But first, the bond. Because before nitrogen can do any of its tricks, it has to be broken. And that's way harder than it sounds. Picture 2 Olympic weightlifters, both massive, both stubborn, and they're locked in a bear hug, so tight, so absolute, that nothing on Earth can pry them apart without a fight. That's a nitrogen molecule. 2 nitrogen atoms welded together by what chemists call a triple bond, one of the single strongest chemical handshakes in all of nature. And here's why that matters to you personally, whether you know it or not. Every plant on this planet needs nitrogen to grow. Every bite of food you've ever eaten traces back to nitrogen getting yanked out of the air and stuffed into soil, which means somebody, somewhere, has to break that bear hug apart billions of times, constantly, forever. So humans built a monster to do it. It's called the Haber-Bosch process, and calling it intense doesn't even cover it. We're talking about cooking nitrogen and hydrogen gas at 450 degrees Celsius under pressures that would crush a submarine like an aluminum can, just to force those 2 atoms apart and bolt them onto hydrogen instead, making ammonia. And here's the wild part. This single invention, this brute force industrial nightmare, feeds nearly half of the people alive on this planet today. Half of everyone. But it comes at a brutal cost. This one process alone burns through about 1% of all the energy humanity uses. Not one factory, not one country, 1% of everything globally, just to break one chemical bond over and over and over. Now here's the part that should honestly blow your mind a little. Go outside, find a patch of dirt, scoop up a handful of moist soil in your hand. Hidden in that clump of mud right now are bacteria doing the exact same trick. No 450-degree furnace, no submarine crushing pressure, no roaring factory, just room temperature. Quiet, using a molecular tool called an enzyme, nitrogenase, that acts like a microscopic safecracker, gently coaxing those two stubborn atoms apart, one single electron at a time. No violence, no brute force, just elegant, quiet precision, built by evolution over more than 1 billion years. And hold up, because here's where it gets messy. This is exactly the kind of thing that sounds simple until you realize we scientists don't actually fully understand how it works. We have X-ray photographs of this enzyme frozen mid-action, literally caught in the act, but the exact choreography, how those metal atoms inside it move, where each proton lands, why this thing works so unbelievably efficiently at room temperature when we need a screaming furnace to do the same job, that's still being fought over in scientific journals right now, this year, as you're listening to this. Papers get published claiming we finally cracked it, and within months, other scientists are picking the theory apart, finding the cracks, sending everybody back to the drawing board. And why should you care about a fight between chemists and lab coats? Because if we actually crack this code, if we figure out exactly what this billion-year-old bacterial trick is doing, we could build tiny artificial versions of it. Farmers could make their own fertilizer on-site, using nothing but sunlight or a trickle of electricity, instead of shipping it from a gargantuan chemical plant burning through 1% of the planet's energy. We're talking about slashing global carbon emissions almost overnight from a solution that's literally been sitting in your backyard the whole time, laughing at our 450-degree hammers. Kind of humbling, right? That nature can pull off at a whisper what we can only manage with a scream. But that bond-breaking trick, that's just the opening act. Because once nitrogen gets loose, it goes and does something even stranger. It gets people drunk at the bottom of the ocean, without a single drop of alcohol involved. Scuba divers have a saying, and it's not a fun one. They call it the rapture of the deep. Jacques Cousteau himself gave it that name, l'ivresse des grandes profondeurs, and it means exactly what it sounds like. Go deeper than about 30 meters, 100 feet or so, breathing regular compressed air, and a strange, creeping euphoria starts wrapping itself around your brain. Colors start looking brighter, jokes suddenly seem hilarious, and in real, documented cases, divers have been known to pull their own mask off underwater because the ocean just looked so welcoming. Some have offered their breathing mouthpiece to a passing fish because in that moment, deep under the water, their brain genuinely believed that was a reasonable thing to do. And that is nitrogen narcosis. It is not a party trick gone wrong. It is a physiological riddle that has killed people. Here's the current theory, and I want you to really sit with this one. Under pressure, nitrogen starts dissolving into the fatty membranes of your actual nerve cells more easily than it normally would. And that causes those membranes to swell. Just slightly. That tiny swelling might be pinching or twisting the microscopic channels that let your brain cells fire messages to each other. Basically, your brain's traffic lights start malfunctioning. Signals slow down. Your whole nervous system starts running like a radio that's slightly off station, all static and weird jazz layered over the normal broadcast. And the deeper you go, the drunker you get. At 60 meters down, divers have been recorded fixating on completely useless tasks, counting their own fingers over and over, while their air supply quietly ticks down to 0. At 90 meters, unconsciousness doesn't slam into you like a wall. It folds you in gently, like a blanket, like a nap, and the sea just takes you. But hold up, here's where it gets even creepier, and this is the part that should genuinely unsettle you. Nitrogen doesn't act like a normal anesthetic. It's not slotting into a receptor like a key into a lock the way most drugs work in your body. This is a brute force physical phenomenon, a raw distortion of the actual machinery of your thoughts. And the truly terrifying kicker, your brain doesn't feel the impairment. You don't feel drunk the way you feel a glass of wine hit you. Divers deep in narcosis genuinely believe they are performing brilliantly, thinking clearly, making perfect decisions, even as the abyss is quietly closing in around them. The rapture is a lie your own brain tells you, right up until the moment the lights go out. And here's why solving this particular mystery actually matters beyond just diving safety. Understanding exactly how nitrogen distorts consciousness could crack open bigger questions about how thought itself arises from membranes and electrical noise in the first place. And practically, it could help us design better breathing gas mixtures so the next diver descending into the dark keeps a crystal clear head all the way to the bottom. And here's the thing that really gets me about nitrogen narcosis. It's not rare. It's not some freak edge case that happens to one unlucky diver in a million. Recreational divers experience some level of it almost every single time they go past that 30-meter mark. Dive schools drill it into students constantly because the danger isn't the narcosis itself. Not really. It's that you don't know what's happening to you while it's happening. Experienced divers have described coming back up to the surface afterward and reviewing their own dive logs, their own handwriting, and not recognizing the decisions they made 20 minutes earlier. One diver, fully sober by every normal definition, will calmly hand their regulator to a fish, and in the moment, in their own impaired mind, that will feel like a perfectly rational thing to do. That's the part that should really sit with you. It's not a hallucination exactly. It's a quiet hijacking of judgment itself, one that leaves no memory of having been hijacked at all. Okay, so nitrogen can get you drunk in the deep, and it can do it without you ever noticing the drunkenness setting in. But here's a question that's going to sound completely disconnected, and trust me, it's not. Where did all this nitrogen even come from in the first place? Because the answer takes us all the way out into space, and it involves a genuine, unsolved cosmic mystery, one that professional astronomers are still arguing about at conferences this year. Take another breath. Go on. That nitrogen filling your lungs right now, it is older than the Earth itself. Every single atom of it was forged inside the white-hot heart of an ancient dying star, then blasted across the galaxy in a supernova explosion so violent it's almost impossible to picture. And then, somehow, across unthinkable distances and unthinkable time, those exact atoms ended up here, in your lungs, right now. But here's the actual mystery, the one that keeps planetary scientists up at night. How did nitrogen end up so ridiculously abundant in Earth's atmosphere when our closest neighbors, Venus and Mars, are almost completely nitrogen poor? Same solar system, same neighborhood of space, wildly different outcomes. It's a cosmic whodunit, and the clues are written in something called isotopes, nitrogen-14 and nitrogen-15, two slightly different versions of the same atom that acts like a chemical fingerprint. And Earth's fingerprint doesn't match a simple mix of the raw material floating around our early solar system. So here's one leading theory, and it's honestly kind of beautiful. In the chaotic early days of our planet, a colossal impact, the same one that's believed to have created the moon, essentially baked Earth bone dry, blasting away any early atmosphere we might have had. And then, for hundreds of millions of years afterward, icy comets and dark, frozen asteroids came screaming in from the Kuiper Belt, way out past Neptune, each one delivering water and a payload of frozen nitrogen. Every single impact was like a tiny kiss of atmosphere, one collision at a time, slowly building up the air you're breathing this exact second. But hold up, because this case is nowhere near closed, and this is honestly where it gets messy for the scientists trying to solve it. Moon rocks tell one isotope story. Samples brought back from the asteroid Ryugu tell a slightly different one. Some researchers think Earth's nitrogen might have bubbled up from deep inside the mantle instead, spat out by volcanoes over billions of years of eruptions. Others think ancient lightning, crackling through a methane-rich early sky, chemically locked nitrogen into gooey organic molecules that simply rained down into the primordial ocean. It is a detective case spanning literally billions of years, with clues scattered across stardust, cometary ice, and the breath of long-extinct volcanoes. And when scientists finally crack it, when we finally know exactly how Earth got its air, we won't just understand our own planet better, we'll know which other worlds out there, spinning around other stars, might be breathing too. All right. Speaking of other worlds, let's actually go to one, because nitrogen doesn't just float around as gas out there. On one particular icy little world, 3 billion miles from the sun, nitrogen turns into something almost nobody expected to find. Pluto, a tiny frozen marble sitting so unbelievably far from the sun that our home star looks like nothing more than a brilliant pinprick in a black sky. The surface temperature out there hovers around minus 230 degrees Celsius, cold enough that ordinary water ice becomes as hard as solid granite. And nitrogen freezes into a glassy solid. So when the New Horizons spacecraft screamed past Pluto back in 2015 and beamed its photos home, planetary scientists sitting in mission control did something you don't expect from seasoned professionals. They gasped, because staring back at them on a supposedly dead, frozen little rock were glaciers, not small ones, vast plains of solid nitrogen ice flowing like frozen honey across an entire region the size of Texas called Sputnik Planitia. These glaciers were creeping, slowly, patiently around entire mountain ranges made of rock-hard water ice, carrying them along like ships drifting on an impossibly slow frozen sea. How? How does solid nitrogen flow at temperatures that would shatter steel? Here's the answer, and it's genuinely strange. Nitrogen ice compared to water ice is basically a softie. Its internal crystal structure is plastic, almost rubbery, so even under Pluto's incredibly weak gravity, it bends and deforms like putty instead of cracking like glass. And deep inside Pluto's core, the faint residual warmth left over from radioactive decay, material that's been slowly cooking since the planet formed, provides just enough heat to keep the base of those glaciers slightly slushy, lubricating the whole creeping, grinding process. But here's the twist. Here's the wait, what moment. The one that had planetary scientists rewriting textbooks in real time. This activity, these flowing nitrogen glaciers, isn't ancient. It's not something that happened billions of years ago and just left scars behind. The surface of Sputnik Planitia is geologically young. We're talking maybe only a few million years old, a literal blink of an eye compared to the solar system's 4.5 billion year history. Pluto was supposed to be a dead world, a frozen corpse, geologically speaking, that stopped changing eons ago. Instead, it's alive, right now, under a star-filled sky on a world we thought had nothing left to say. Nitrogen is quietly, patiently sculpting an entire landscape as we speak. Which means the mystery isn't how did this happen? The mystery is it still happening? And if a tiny frozen marble at the edge of our solar system can still be this dynamic, this alive, what does that mean for every other icy little world out there we've written off as dead? Okay, so nitrogen builds glaciers on distant worlds. It gets divers drunk in the deep. It came here on the backs of ancient comets. But now, and I need you to really sit with this next part, we're going to talk about the side of nitrogen that has actually killed people, quietly, without a single warning sign. And the reason why is honestly one of the creepiest things your own body does. Every single year, in industrial accidents around the world, workers walk into confined spaces, storage tanks, sealed rooms, cargo holds, where liquid nitrogen has boiled off or a nitrogen line has leaked. And here's the thing, there's no odd smell, no visible fog rolling across the floor, no sudden chill hitting your skin. The nitrogen just quietly, invisibly pushes the oxygen right out of the room. And the person walking in? They breathe normally, they feel completely fine, maybe just a little lightheaded, the kind of feeling you'd brush off as nothing, and then, without a single second of panic, without ever once feeling like they were suffocating, they drop unconscious. Minutes later, the heart simply stops, and when investigators do the autopsy afterward, there's no sign of struggle, no agony on the face, just someone who looks for all the world like they peacefully fell asleep. That is genuinely one of the most unsettling facts I've ever come across, and here's why it happens. It comes down to a blind spot baked into human biology itself. Your body does not have an oxygen alarm. What you feel as that desperate, clawing panic when you're suffocating, that's not your brain sensing low oxygen. That's your brain sensing rising carbon dioxide in your bloodstream. Go ahead, try holding your breath right now. That screaming urge to gasp for air isn't coming from your oxygen levels dropping, it's coming from CO2 building up. So, here's the horrifying part. Breathe pure nitrogen instead of regular air, and your body keeps calmly exhaling CO2 with every single breath, just like normal. No CO2 buildup, no panic response, ever. Your brain simply quietly dims, like somebody slowly turning down a dimmer switch on a light. You feel a little euphoric, maybe a bit clumsy, and then nothing. And get this, because of exactly how clinically calm this process looks, nitrogen has actually been used in legal executions in some places, a practice that remains deeply controversial precisely because it looks so peaceful from the outside. So here's the real mystery underneath all of this. Why on earth didn't we evolve a direct sensor for oxygen itself? Because some animals did. Aquatic turtles, diving seals, they've got far better built-in tolerance and sensing systems for exactly this kind of danger. Our failure to develop the same thing is just a quirk of mammalian history. Our distant ancestors almost never encountered air that was oxygen poor without also being thick with carbon dioxide. Pure nitrogen displacement, the kind that happens in a modern sealed industrial tank, is a brand new threat invented by the industrial age, and our ancient internal hardware simply never caught up to meet it. Understanding this exact gap in our biology could genuinely save lives. In space capsules, in submarine habitats, anywhere an inert gas leak could turn deadly in total silence. Nitrogen's silent kiss is proof that evolution isn't some perfect designer working from a master blueprint. It's a patchwork, full of blind spots, and the single most common gas in the air around you is hiding directly inside one of the biggest ones. And this isn't some abstract, theoretical danger locked away in a textbook. Safety agencies that investigate industrial accidents flag confined space nitrogen asphyxiation as one of the most persistent, most preventable causes of workplace death year after year, precisely because it fools everyone the same way every single time. A worker sees a colleague collapse just inside a doorway and, thinking it's a heart attack or a stumble, rushes in to help, no mask, no hesitation, and they go down too, seconds later, for the exact same invisible reason. It's such a well-documented pattern that it has a grim nickname in the safety world, the would-be rescuer effect. The very instinct that makes us human, running towards someone who needs help, is the thing nitrogen weaponizes against us. That's not a flaw in any one person. That's a gap in all of us, baked in from millions of years that never had to plan for a sealed steel tank. But hold up, because everything we just talked about, the killer, the glaciers, the ancient comets, the drunken depths, all of it has been leading towards one final quiet twist. Something so ordinary you've looked directly at it every single day of your life and never once questioned it. And once you hear this, I promise you, you will never look up at a clear blue sky the exact same way again. Think about the sky. Right now, wherever you are, picture that calm, clean, pristine blue stretching overhead. Feels obvious, right? Sky's blue, always has been, nothing to question there. Except, It's kind of a lie, or at least a very carefully negotiated truth. Here's the actual physics, and stick with me because this is where it gets messy in the best way. There's a phenomenon called Rayleigh scattering, and it basically says that when sunlight slams into nitrogen and oxygen molecules up in the atmosphere, shorter wavelengths of light get scattered around way more violently than longer ones. And violet light has a shorter wavelength than blue light, which means if pure physics alone were painting the sky above your head, it should not be blue at all. It should be violet, maybe even washed through with ultraviolet, a color that birds and bees can actually see and that you and I never will. So why blue? Turns out there are two co-conspirators hiding behind the color of your sky. First, the sun itself. Its light isn't a perfectly even rainbow of equal brightness across every color. It actually peaks in the green-yellow range and drops off sharply toward the violet end. So there's simply less violet light available to scatter in the first place. And second, and this is the part that gets me every time, it's your own eyes. The human retina has 3 types of color-sensing cone cells: red, green, and blue. Your blue cones get weakly tickled by violet light, but they light up way more strongly for pure blue instead. So even on the rare occasion violet photons do hit your eye, your own brain reinterprets it and hands you back a shade of blue. A trick of biological interpretation running constantly every waking second of your life. And here's the genuinely mind-bending part to close on. A creature with different eyes, say a bee that can see ultraviolet, or some hypothetical alien with 4 different types of cone cells, could look up at that exact same sky and see a completely different color, a lilac dome, a brilliant violet arc. The sky's blueness isn't some fixed, unshakable property of nitrogen sitting up there in the atmosphere. It's a 3-way collaboration between a star 93 million miles away, a molecule too small to ever see, and the peculiar biological machinery humming quietly inside your own skull. Reality, if nitrogen has taught us anything today, is never just sitting out there waiting to be observed. It's always a co-production between the world and whoever happens to be looking at it. The sky isn't blue. You and the sun and a silent, invisible gas you've breathed 20,000 times today, without a single thought. You make it blue, together. Think about everything that one invisible gas just did in front of you. It fed nearly half the people on this planet, and it did it by way of a bacterial trick living in the dirt beneath your feet that we still can't fully explain. It quietly hijacked the judgment of divers 100 feet underwater so gently that none of them ever felt it happening. It rolled in on the backs of comets across billions of years of solar system chaos, and we're still arguing about exactly which comets and exactly when. It's flowing right now as a glacier on a dwarf planet that was supposed to be dead. It has ended lives without a single second of struggle or fear, simply by exploiting a blind spot baked into the very biology that lets you breathe at all. And it bends starlight into a color your own brain has to negotiate into existence every single time you look up. None of that required nitrogen to do anything unusual. It just had to sit there and be nitrogen in 6 different sets of circumstances. That's the whole punchline. The most forgettable substance in your world was never actually simple. We just never bothered to look closely enough to notice. So next time you take a breath, and you're going to do it again in about 3 seconds, whether you think about it or not, remember what's actually riding along in there. The ghost that feeds half the planet and could just as easily take a life without a sound. The thing that gets divers dizzy in the deep and paints frozen rivers across a dead but not quite dead little world at the edge of everything. We didn't even get to nitrogen's role in your own DNA today, or in explosives, or in rocket fuel that carried human beings to the moon and back. That's a whole other story, and honestly, it might be even stranger than this one.